Hello student, this is Omprakash Yadav. Today I am going to teach you that what is the interference in the involute tooth profile. Actually, interference is a problem with the involute tooth profile. Today I am going to explain that what is the interference, how the interference will come, and what is the undercutting in involute tooth profile. Okay, so before going to discuss this, let us understand first this figure. Then from this figure, I will be able to explain actually what is the interference in involute tooth profile and what is the undercutting in the involute tooth profile. Let us come and understand. So at the top, I am taking the gear. At the bottom, I am taking the pinion. Okay, I have taken this pinion as a driver and this gear as a driven. I have drawn three circles for each. So this is the gear. So this is the base circle of gear. This is the pitch circle of gear, and this is the addendum circle of gear. Now let us see for the pinion. So this is the base circle of pinion. This is the pitch circle of pinion, and this is the addendum circle of the pinion. Addendum circle of the pinion. Already I have discussed that this is the common tangent at the point of contact. Sorry, at the pitch point. This is the pitch point. Where is the pitch point? Where the pitch circle of the two gear will touch to each other. So this TT is the common tangent at the pitch point, and this is the common normal at the point of contact. This MN is the common normal at the point of contact, and already you know that common normal at the point of contact is also common tangent to the base circle. That common normal at the point of contact is also common tangent to the base circle. You can see that this line is also tangent to this base circle and this base circle both. So common normal at the point of contact is also the common tangent to the base circle. Okay. Now look at here. This K is the start of engagement. This is the pinion is driver. So this is rotating in this direction. So engagement of the tooth of the pinion with the gear will start at the point Q. So this point Q is the start of engagement. Then the point of contact Q will travel from Q along the common normal at the point of contact. So as the pinion is rotated, this point Q is traveling along this, reaching to the pitch point. Then they are going here. Then this is the end of engagement. That is engagement means end of here. So this K is the start of engagement, and this L is the end of engagement, and this is the pitch point. Already I have explained that this KL is the path of contact. Path of contact. This KP is the path of approach, and the PL is the path of recess. Okay, but here, just for the basic, I have explained these basic things with this figure, but our objective is to explain actually what is the interference. So, let us understand what is the interference. Look at here, if you start increasing the addendum circle radius of the gear, suppose this is the gear, if you start increasing the addendum circle radius of the gear, that is this one, then what will happen? You can see from here that this is the K, start of engagement. So as addendum circle radius of the gear increases, so that will go. So up to the point M, means this K has come up to the point M. Yeah, radius of the gear becomes O2M, there is no problem. So up to the radius where radius of the gear has gone beyond, up to the radius O2M, there is no problem. But if you again increase the radius of this addendum circle radius of the gear beyond this point M, then there will be an interference. Why there will be the interference? Because tip will enter into the non-involute flank portion of the pinion. I will understand from this. Okay, so up to the point M there is no problem. Similarly, we can say that as the addendum circle radius of the pinion increases, so this point L, end of the engagement, will shift. So up to the point M there is no problem. So as this end of engagement is moving, as the addendum circle radius of the pinion increases, this point L is shifted towards the point N. Up to the point M there is no problem. Up to the point M, there is no problem. But if you increase the addendum circle radius of the pinion beyond this point M, then there will be the interference. Actually, what will happen? The tip of the pinion will enter into the non-involute flank portion of the gear. That will happen. Okay. So when the point Q, which is the common point of contact, is traveling in between M and M, there is no problem. When they are going beyond M and M, then there is a problem of involute. Okay, so this point M and M is known as the interference point. So this point M and N is known as the interference point, and this is the limiting point. Up to point M and N, there is no problem. Okay, but let us see that when you are going to increase the addendum circle radius of the gear, this point start of engagement is shifted up to the point M, there is no problem. But when the addendum circle radius of the gear increases beyond this point M, then what will happen? Let us see here. Look at here. So here this is the gear and this is the pinion. Look at here. I have taken here one tooth only to explain the fundamental. This is the root circle of the gear and this is the base circle of the gear. You know that above the base circle tooth profile is involute, that is, this is the involute tooth profile, but under the base circle, that is this tooth profile is not involute. This is what the non-involute. This is non-involute. So this is also non-involute. Similarly, this is non-involute. And this is also non-involute. So this one is involute, and this portion, and this portion is non-involute. So I have told that if the addendum of the gear will increase, then what will happen? The tip of the gear, this is the gear tooth, then the tip of the gear will enter into the non-involute portion of the flat. So this gear tip is touching the non-involute portion of the pinion. So non-involute portion of the pinion. Now then what is happening? This tip of the gear is removing the material from this flank portion of the pinion. So what is the interference? This is the interference. So what is the interference? When involute portion of the gear is interfering the non-involute portion of the pinion, or similarly we can say that when this tip of this pinion is touching the non-involute portion of the gear. So both are the interference. So what is the interference? It is the contact of tip of one tooth to the non-involute flank portion of the another gear. That is known as the interference. So what is the interference? It is contact of involute tip to the non-involute flank portion of the pinion. So that is known as the interference. So when the law of gearing will not be satisfied, because this tip is involute, but this flank portion is non-involute. So here law of gearing will not be satisfied, hence velocity ratio will not be exact. No exact velocity ratio will be transmitted during this contact. Okay. So what will be problem? What is the problem if there is the interference? If there is the interference, then this tip of the gear will not slide properly here. So that will not be tangent actually. They are digging into the root of the pinion and they are removing the material from here. So material is not only removed from this root of the pinion, but also from this involute tip of the gear. So material is not only removed only from the root of this pinion, but also from this. So what is happening? From here and here, this both material are removed. So that is known as the undercutting in the involute tooth profile. So that is the undercutting in the involute tooth profile. Okay. So what you can do to avoid it? You can remove this material. Already you remove this material so that this tip of the gear cannot mesh with the root of the pinion. In that way, you can avoid the interference. That is known as the manufacturing of the tooth by the generation process. Later on, I will see that what is the method to avoid the interference. So I think you will be able to understand what is the interference. Again, I am trying to explain you that what is the interference. So, when this tip of the gear is touching the non-involute portion of the pinion, non-involute flank portion of the pinion, then law of gearing is not satisfied because one is involute and the other is non-involute. So that contact of involute to non-involute is known as the interference. Due to that, material from the root of the pinion and from the tip is removed. Similar phenomena will happen when the tip of the pinion will touches the non-involute portion of the gear. Same physics, same phenomena will happen there. Okay. Now, one thing I am going to see that is a very interesting phenomena. So, I have told that either you increase the addendum of gear or you increase the addendum of pinion, but that is not the case. Because for the machine gear, addendum of gear and pinion are same. Addendum of gear and pinion are same. So you have to increase the addendum of both the circle, both the gear and pinion simultaneously. So what should be there? Simultaneously you have to increase addendum circle radius of both gear and pinion. Both gear and pinion. When you do this, then you get that. What you get that? Look at here. So when you increase simultaneously addendum circle radius of gear and addendum circle radius of pinion, then this point K starts shifting in this direction and this point L will start shifting in this direction along this common normal at the point of contact. So first, when you are increasing the addendum circle radius of gear and pinion both, then first this addendum circle radius of the gear reaches the limiting interference point. So first this K reaches the point M and this point L reaches the point N later. So you can say that I can conclude that first interference start from at the tip of the gear, and the root of the pinion. So first interference take place at the tip of the gear and the root of the pinion or flank of the pinion. So first interference take place between the tip of the gear and the root portion of the pinion. Then if you again increase the addendum circle radius, then this point L will teach to the limiting interference point N. But if already interference has started at the tip of the gear and the pinion, then I can say that interference has started. Don't wait to reach that point up to the point N. So interference has started. So first interference is started at the tip of the gear and the root of the pinion or flank of the pinion. That is very interesting thing. Also that are useful to calculate the minimum number of teeth on the gear. This concept is needed to know that you have to calculate the minimum number of teeth. How? So minimum number of teeth, first to calculate the minimum number of teeth on the gear, then you have to find out the minimum number of teeth on the pinion. So in a lot of the yesterday material wrongly they have presented, but that is not the case. So very precisely you have to understand this thing, that first interference occurs at the tip of the gear and the root of the pinion. Okay, so by considering that, you have to derive the expression for minimum number of teeth on the gear. Then by using the formula of gear ratio, that is capital T bata K small t. So capital T minimum bata K small t minimum, you can get the minimum number of teeth on the pinion. Okay, now so interference is the problem. Interference is the problem. Then how to avoid the interference? Let us find out some solution, some measure how to avoid the interference. So first method to avoid the interference is that manufacturing by the generation process. Manufacturing by generation process. Manufacturing by generation process. So you have seen that tip of the gear is touching the non-involute flank portion of the pinion. So already you remove the material from the flank of the pinion. If already by the manufacturing process you have removed the material, then the tip of the gear will not touch the non-involute portion of the pinion, so there will be no problem. So in that way interference can be avoided, but there is a problem that root of the gear or pinion, जहाँ से भी आपने material को remove किया, undercutting किया है, that becomes weaker. That is the problem. So you cannot remove more material. Otherwise the weak becomes stronger. So this is the one method. Let us see the another method what you can do that. So very clearly I have explained that interference first started at the tip of the gear and the root of the pinion. So what you can do that you cut the some material from the top of the gear tooth. So what will happen? So tip of the gear will not touch the root of the pinion. So in that way also you can avoid the interference. So that teeth, when you are cutting from the top little bit, that is known as the stub tooth. क्या बोलते हैं उसको? That is known as the stub tooth, not the full depth involute. That becomes what the stub tooth. In that way interference can be avoided, can be reduced. But again there is a problem, little bit problem. What is the problem? The path of contact will decrease, arc of contact will decrease, and also the contact ratio will decrease. If this thing will decrease, then again there will be another problem. So we can go only up to a very small limit. We can't go beyond that limit. Okay, so this is the another method. Let us see the third method. What is the third method? Just suppose this is the common tangent at the point of contact, and I am taking this base circle of one gear, and this is the base circle of another gear. So what is this? This is the common normal at the point. This is the base circle of this both the gear, and this is the common tangent. So this is what yan dash, or say this yam. So this is the common normal at the point of contact. This is also common tangent to the base circle. Acha, if you are increasing the pressure angle, means what? You are decreasing the base circle radius. When you are decreasing the base circle radius, then you can see that this is the initial pressure angle phi 1 and this is the final pressure angle phi 2. So from here you can see that phi 2 is greater than phi 1. Phi 2 is greater than phi 1 means what? So by increasing the pressure angle, you can reduce the chance of interference. How? By reducing the non-interfering material, non-involute portion of the flag. So in that way what actually you are doing? You are decreasing the non-involute portion from the flag. So, but again there is a problem, little bit problem. What is the problem? You know that force transmitted in this direction is given by F cos phi. So this is the force transmitted from one to the another. So if the pressure angle will increase, the force transmitted will decrease. So that is another problem. So you cannot go beyond that limit. Or there are another method also. Increase the number of teeth on the gear and pinion. By increasing the number of teeth on the gear and pinion, also interference can be avoided or can be reduced. But so when you are increasing the number of tooth, their module will decrease. When you are increasing the number of tooth on a surface, then the module will decrease. Will decrease. The depth of the tooth will decrease, and that will decrease the path of contact, arc of contact, and the contact ratio. That is another problem. So these are the measures by which you can decrease or you can eliminate the interference from the involute tooth profile. Okay, one thing more I want to discuss here, that in competitive examination, people is asking that I have told that in involute tooth profile, what I have told to you that in involute tooth profile, center distance between the shaft little bit can be increased without changing the velocity ratio. Acha, but if you are increasing the center distance between the shaft, then what will be effect of this? In so many competitive examination, they are asking what is the effect of increasing the center distance between the shaft in case of involute tooth profile. So answer is that what will be effect? First thing is that law of gearing will be satisfied. There is no problem. Law of gearing will be satisfied. The pressure angle will increase. If you are increasing the center distance between the shaft by making the two diagram, you can understand this. So pressure angle will increase. Pressure angle will increase. What about the base circle? This is the property of gear that will not change. Another thing is that path of contact, arc of contact, and the contact ratio will decrease. Path of contact, arc of contact, and the contact ratio will decrease. Contact ratio will decrease. If the contact ratio will decrease much below, that is below the one, then there will be impact loading from one tooth to the another tooth, or from one gear to the another gear. So that is again the problem. Okay, thank you very much.